Welcome to physics class revision, and today we are going to concentrate on 2024 physics revision class, and this is going to be a moving forward for you to write your physics exam in 2025. Okay, I'm also welcoming students and colleagues and teachers and other people who are interested in this kind of video. Let's get started. I'm going to be pressing the question for you to see the question why I use the one I have here to be solving them. All right, let's get started. All right, the first question I'm going to solve here is saying that the first question says surface tension. We should find the dimension of surface tension. All right, the dimension of surface tension can be found by first you knowing the formula for surface tension. And surface tension is given as force all over length. Force per unit length is the formula for surface tension. So when you know the force per unit length, the next thing you are going to do is to break this force down. So force, the formula for force is given as mass times acceleration. And what is the dimension of mass? It's capital M. What is the dimension of acceleration is L t raised to power minus 2. Why the dimension of length is also length is capital L. Therefore, the surface tension has a dimension of M L t raised to power minus 2 all divided by L. Okay, remember this L is going to cancel L. We now have M t raised to power minus 2. This is the dimension for the surface tension. That's number 1A. That is number 1A. So number 1B, we are asked to find the instrument used for measuring the force of gravity at a place. Force of gravity at a place can be measured using a spring balance. Spring balance can be used to measure. If you look at the spring balance, this is what it is. This is the spiral spring and a hook where you can now hang the object. You use this to measure the force of gravity at a point, or you can also use the one they call gravitometer. Yes, yes, gravimeter. All right. So we are not here. We are not really used to this one, but this is the spring balance. We are used to it, and this is what it can be used to measure the gravitational force of a place. Number two, they say that in number 2 question, they say we should state the two uses of polar satellite. When we talk about polar satellite is a kind of satellite that orbits along the poles. All right, it orbits along the poles, and the uses of such polar satellite is because it gives, number one, you can say that number one, it gives a global coverage. It gives a global coverage. It can also help for the prediction of weather or atmospheric changes. It can also be used to provide information on information about the weather changes. So these are the things you can use global satellites for. The next one they ask us is number 2. What does the tensile stress? You say, what does the graph of tensile stress against tensile strain means? Tensile stress. When we talk about tensile stress, we are saying that in a graph like this is stress, tensile stress against tensile strain. So if they plot a graph, what is going to be the slope? Now, what we should know first is what is this stress and strain? Remember that we said that stress is highly proportional to strain. Then if I remove this proportionality, I'm going to say that stress, let me use S sub t, and is going to be equal to a constant and S sub n. This is strain, this is stress. So if you have this is called the constant of the proportionality between the stress and the strain. And that means if I make this particular constant the subject formula, we have tensile stress all over tensile strain. And that means the graph of the slope of tensile stress and tensile strain, because they are directly proportional, is going to be a straight line graph. So the slope, that is change in the tensile stress and the change in tensile strain, is going to be Young modulus. Young modulus is going to be the answer. Okay. Okay. So let us clean the board and continue with number 3. Okay, number 3, they said is state the base unit of the following physical quantities. So we have stress. I mean, Waec has been coming with the questions on stress and strain in the last 2 years. Last year, a lot of questions came from stress, that is elastic properties of matter. So it's another very important topic we need to study. So we said we should find the SI unit of tensile stress, and another one is force constant, and another one is Planck's constant. Yes, Planck's constant. All right, so let us find their base unit. Base unit means I'm going to break them all down to their basic SI unit. Yes. So stress, when we talk about stress is something as force per unit area. Force per unit area at a point on a surface is the stress. Therefore, what is force? Force is given as mass times acceleration all over. Area, the formula for area is given as meter squared, or L squared, sorry, not meter squared, L squared. So for that reason, we are going to say that mass is, mass is given as kilogram times acceleration is given as meter per second squared, then while length is given as meter square. All right, so this is the base unit. What we do is that there is m here, m is raised to power 1 and m is raised to power 2. What do we do is they subtract each other. So we are going to have that m cancel one of this one. Have that kilogram, m raised to power minus 1 and s raised to power minus 2, because the one here is going up to become minus. So that is for that. Number 2, force constant. According to Hooke's law, force constant is given as H is equal to KE, whereby K is the force constant, which is given as, according to Hooke's law, that is bad. According to Hooke's law, F is equal to KE, not this place. So whereby K is the force constant and the force constant is given as F all over E. What is F? F is still the force, and what is the SI unit of force, which is kilogram meter per second squared all over. What is E? E is measured in length, which is given as m, right? So this we cancel this. So the force constant is given as kilogram s per second square. All right, so this is the SI unit of force constant, which is this number 2, force constant. Force constant, which is almost the same formula with surface tension. All right, so the next one is Planck's constant. Remember, according to Planck, he said that E, energy, is given as hf. So where is this h is the Planck's constant. So Planck's constant is given as E all over frequency. Now what is E? E is energy measured in joule. What is joule? Joule is work, which is work, and work is something as force times distance all over. Frequency is 1 over time. Yes, 1 over time is frequency. So let's keep going. So the SI unit of force is given as mass per seconds. The force is something as kilogram meter per second squared minus times s. S is something as distance, remember, times m. This s is representing the m because the SI unit of distance is meter all over. This is 1 all over seconds, because SI unit of time is seconds. Remember the confusion between this s and this. This s is for the distance, because work is force times distance. This s is the distance. In physics, that's what they usually use. Why this s is for seconds, which is the SI unit of time. So know the difference. All right, so what do? We are going to open the bracket. We have that there is no bracket here, please. What we are going to do is to simplify the numerator. M times M. M is raised to power 1. M is raised to power 1 here. Is going to be M raised to power 2. And this is S. S raised to power minus 2. All over. This one is going to be S raised to power minus 1. And this one is going up to become plus. So this is going to be kg M raised to power 2. S raised to power minus 2 plus 1, because this one is going up to be plus 1. So we break down later. We have that kilogram mass squared, or meter square, and S raised to power 1 minus 2 is going to be minus 1. Therefore, this is the base unit of Planck's constant. Okay, number 4. Okay, number 4 is calculation. So let us clean the board and continue with the solution. All right, number 4 says an object is projected at an angle to a level ground, has a time of flight 4 seconds. All right, it has a time of flight 4 seconds. So total time of flight is given as 4 seconds. I'm going to explain this, what it means. To move through the air, calculate the height attained by the object. Okay, see, if this is the projectile plane on the horizontal axis, and this is the vertical plane as well, and the body was projected like this, okay, see what happens. That means the body has moved from here, point A, to point C, but there is a particular place it will get to, because the body was moving up. At a point, it reached the maximum height, then start going down. Therefore, this is the height called maximum height. Remember, it is projected at an angle, and there is a speed with which it was projected. All right, so what you understand is that this time called total time is the time it takes to go from A to B and down to C. But for me to be able to calculate this, I'm going to say that the time from A to B is 2 seconds. They divide it into 2, because the time taken to reach the maximum height is half of the total time of flight. And then another one is from here to the down is also 2 seconds. All right, for me to find the maximum height, I'm going to say that at maximum height, u sub y is 0. That means the vertical component of the speed of the body at the maximum height is 0. But I also know that there is another speed, which is v sub x, which is the horizontal component of the speed, is still there, which is unknown at this point. So what I'm going to do is going to use the formula for height. I'm going to say v squared is equal to u squared plus 2gh. I think this formula can help us, because at maximum height, okay, I'm not using this, because for me to use this formula, I must have either the final velocity or the initial velocity. So in this case, it's not going to help me, so I won't use this one. I will use the other formula, which is the height h sub y, which is equal to u sub I times t plus half gt squared. So if you look at this very well, I'm looking at from here down to this place, and if you check where the time is going to be, t is going to be 2 seconds, because the maximum height here is what I'm looking for, and the speed at the maximum height is 0, because the body did not continue going up, the body changed. Therefore, the maximum height is going to be, this is 0, half times g, we were told to use g as 10 times, what is t? T is 2 squared. This is 5. 5 times 4 is what? 20 meters. So that is the height attained, or the maximum height of the projectile. Number 5, they say state 3 uses of ferromagnetism. Ferromagnetism, right? Okay, so the question should be, what is ferromagnetism? What is ferromagnetism? Ferromagnetism is just like a material which is easily magnetized. That means the ability for a body to be magnetized by such materials is very easy. And such materials can be found in transition element in periodic table. But then what can you use such materials? And those ferromagnetic substances or ferromagnetism, sure, is correct. Yes, ferromagnetism. Those materials include iron, let's say cobalt, nickel, and we can even say manganese. So these are materials that are called ferromagnetism. The question should now be, I think steel is also there, etc. There are many. Now the question should be, what do we use these materials for? Because the question is, state 3 uses of ferromagnetism. And ferromagnetism are these materials. What do we use it for? Number one, I can say that it can be used as the core of a solenoid. Because the core of a solenoid is just an iron bar which was used to coil. We can be used. It can also be used in making electromagnetism, used in making electromagnet, not electromagnetism, electromagnets. It can also be used in making cooking utensils at home, like iron, like stainless steel or pots. So these are number 3 can be used for making transformers. Can be used in the core of transformer. So transformer. So these are the things you can use ferromagnetism to do, or ferromagnets. Number 6, all right. In number 6, we say that an electron of mass m and charge E moves through an electric field PD, so V sub naught. He said with speed V, show that the Broglie's wavelength associated with electron is given as. They want us to show that the Broglie, this is the Broglie. Some people call it the Broglie, but the Broglie is fine because it's a French name. The Broglie is given by, this is the wavelength of the Broglie's wavelength, is given as h all over square root of 2 E m V naught. How did they write it? 2, okay. 2, the first root m, E, and V sub naught. So they want us to prove that this is true. Now, from the question, you see that an electron of mass m and the charge E moves. That means there is a kinetic energy there. It moves. So what is the kinetic energy there? Okay. Remember that kinetic energy is there given as this, half mv squared, whereby the m is the mass of the charge moving in that place, just like in production of X-ray, right? And also remember that this is given as E V sub naught, which is E is the charge, the quantity of charge, whereby V sub naught is the potential difference. Sometimes we call it stopping potential, which is the potential difference at the target in the production of X-ray. I'm going to post a little clip for you to watch what I'm saying. All right, so at this point, I can quickly say that this implies that electron volt is given as 1 all over 2 m v square. Of course, that makes sense, right? Because if kinetic energy is half mv square and kinetic energy is E sub naught, it simply means that this must be equal to this in this equation. Therefore, I'm going to say that V is equal to 2 E V sub naught divided by m, then with square root. I mean, making V the subject formula here. All right. So if you make V the subject formula, 2 is going to multiply this, divide by m, and take the square root. So I've taken the square root of all of them. So this is V for equation 1. All right. The next one, I'm going to say that I will solve this in 2 ways. The next one, I'm going to say that from this guy, which is the Broglie's wavelength, is given as Planck's constant all over mv. Therefore, from this place, I'm going to say that this implies that mv lambda is equal to Planck's constant. Therefore, v is given as Planck's constant all over m lambda. This is equation 2. Now, I have that v is this, And I also have that V is this. Just like we said that this is this and this is this, then this must be equal to this. In the same way, if V is this and also V is this, that means these two of them are the same thing. So I can equate them. So I'm going to equate equation 1 and equation 2. We say that square root of 2e sub naught all over m is equal to h all over m lambda. Okay, so at this point now I have this formula. In order to remove this radical, which is the root, I'm going to square both sides. So I'm going to have this. So when I square both sides, this cancels this. I have 2e sub naught all over m is equal to h squared all over m squared and lambda squared. All right. So I'm going to make lambda the subject formula and I will get my answer. All right. So at this point, I have that I'm going to, clear the fraction. I'm having that m squared lambda squared times 2e v sub naught is equal to h squared m. All right, so at this point, okay, this is squared. This is squared. I was surprised. So one of these is cancelling the whole of this. Come. Don't make noise now, please. All right, so I'm going to make this the subject form. I said that lambda squared is equal to h squared all over 2. Okay, I'm looking for, okay, m comes first. 2m e goes there and v sub naught. All right, so I'm going to take the square root of both sides. So in order to cancel this, if I take square root of this, I'll take square root of this. This cancels this. All right, I have that lambda is equal to h all over square root of 2m e and v sub naught. Okay, somebody will say, what happened to this? Square root of h square root of h square is only h. So that is only h, but this one, the square root goes for the denominator because it does not have a square. It's not a perfect square. So this is what you are looking for. Maybe I should do another way of doing this. No, I think this is enough. And the last question, which is number 7, we'll be back to solve it. All right, the last question, which is number 7. Now, the question says the fractional change in length produced in an elastic material of spring constant 680 Newton meter when a force of 260 is applied to stretch it is 1.5. They said calculate the original length of the material. All right, you see that particular 1.5. Does it have any unit? No, it does not have a unit. For it not to have a unit, that means, you see that word fractional change in length was so deceitful. And if some people were saying that it is change in length, it can't be, because change in length would have been 1.5 meter. They would have given a unit. But since, a unit, yes, since the unit was not given, therefore it can't be change in length. It should be strain. Because strain is same thing as E all over original length. In this case, there is no unit given. Therefore, I'm going to say that strain is 1.5. So I'll have 1.5 is equal to E all over L, equation 1. All right. Then the next one they gave us is according to Hooke's law. Hooke's law said that force is equal to KE. Force is given as 360. Force constant was given as 680, and I do not know E. So what I will do now is to say that E is equal to 36 over 68. 0 will cancel 0, which is the same thing as what? So 36 divided by 68 is given as 9 over 17. So that simply means that if I substitute E here, I can find the original length. Therefore, I'm going to have that 1.5 is equal to 9 all over 17L. So I'm going to say that L is equal to, okay, I think should continue now, is equal to 9 all over 1.5 times 17. So L is 17 as, let's say, 9, 1.5 times 17 is 25.5. So 9 all over 25.5, L is given as 9 divided by 25.5. So this is 0.353 meters. Okay, I was not given to any unit. So to 2 decimal places or 3 decimal places, that is the value of the length. So this is the part 1 for physics 2024 question, and this is a revision for those of you writing exam in physics, GCE, NECO, and even JAM. Thank you for being part of this class. Remember the right thing to do. Always hit the subscribe button, like this video, and share it. Have a nice time, and I wish you good luck.